Hi, everyone. Thank you for joining. And welcome to our Oracle Database in-memory Summit. Um, so again, let me go to next slide. Very, very welcome. There are people joining from around the globe here, customers, partner, consultants, Oracle teams. Thank you all for joining. This summit is about you. We are hosting the summit for you. We are all excited that you have joined here. And the summit again will have content for everyone, whether you are an existing customer or user of in-memory, or whether you are kind of just getting started to in-memory. And so, the last time we did a summit in 2021, and since then we have made a lot of progress and advancements in the in-memory area. So we thought that, hey, why not get together and kind of show all the advancements that we have made. So one stream of presentation will cover all the new customer-driven innovations in the in-memory area in 21C and 23C. Then we have a lot of different customer success stories that we will cover here, okay? And these are, again, success stories coming across the globe. We'll also talk about the kind of a summary of use cases that we see with our customers and how they use in-memory and all. So stay tuned. Also, let's collaborate at this summit. Feel free to ask any question. Summit is all about kind of bringing all our minds and ideas together. Share your business requirements, use cases, suggest any enhancements, provide us feedback, and so forth, right? And also, most importantly, let's continue the discussion after the summit, okay? We are here to help you get started. We have all the PM team here. We have dev lead here. We are all here to help you get started, okay? We can organize technical sessions for you at your company, workshops, use case validation, POC support, and anything, right? So we'll help you get started. So let's continue the discussion even after the summit. This is the kind of a high-level agenda, and we'll talk more details on the next slide. We will have the keynote presentation from Shasank, and we have the technical update, and then a lot of different, customer presentations from India and China that we'll cover today. In case you missed the session one, it has been recorded. So we will upload the recording at some point. There were, again, various customer success stories as part of this session as well. So please, when you get the recording, please do see watch those recording as well. So we are here in session two. This is the agenda, detailed agenda. Keynote presentation initially, then what new features in 23C, and as well as part of it will cover 21C as well. Then, database in-memory implementation at Fidelity will cover. Then various success stories in China and Hisense, and also for a top financial services customer in India. So again, there's various customer presentations lined up here, and stay till the end. So let me start with some background before I hand over to Shasank for his keynote. Organizations like yours, everybody has a lot of business questions, right? And the number of questions and the data points are increasing day by day, okay? And these business questions are, reports, the BI tool queries, the ad hoc queries, dashboards, KPIs, and people are looking for patterns and trends in the data. These are kind of analytic queries that we are focused on today. And the key point here is that everybody is running analytics, and the number and type of analytics is kind of growing every day. Now, on the other hand, all the business they want is fast answers, but they get delayed answers, okay? And the delayed answers leads to lost business opportunities, right? And what is happening is that the reports that are critical reports, they are getting delayed. The dashboards and KPIs are not up to date in real time. And the LOB reports are missing SLAs. There is time lag due to complex architecture because people have to copy data to another system to run reports. There are system performance bottlenecks and issues because there is a rapid data growth or analytics growth and all. And because of ad hoc queries and all, people have to kind of re-optimize every time, okay? So a lot of challenges happening that we see across the customer shops, right? And hopefully this resonates with some of with your organization as well. So there is a value gap in extracting, some value from the data, right? So there is a gap that exists in the market, okay? If you see here, x-axis and the y-axis, there is a longer time to extract value because of delayed analytics. It limits your ability to execute and all, okay? And what would happen if you could get the answers right at the time of data generation? Okay, this is what is called real-time analytics. And this could lead to faster time to market, faster to react to business opportunities and better business decisions and all, right? But on the other hand, what happens is that because people use a lot of point solutions and because they spend most of the time moving and copying data, because they use complex architectures, many times these analytics kind of they cause those delayed analytics and all, okay? So the overall goal and the vision for all of us should be to how do we move to the real-time analytics rather than have delayed analytics in our organizations. There are also a lot of emerging business requirements, opportunities coming in where there is a need for just-in-time analytics. Like if somebody's at store, how do we provide a promotion when the customer is at store rather than when they have left the store, right? So just-in-time analytics, and the speed is of the essence there. Again, kind of concluding here, speed can change the way you think about your business. It can lead to better customer experience, new product and service differentiation, improve quality of service, and so forth, right? Given all this background, let me invite Shasank to give his keynote presentation. Shasank, could you start sharing your slide? Meanwhile, I'll do your quick intro.
Sure.
Shasank Chavan is the Vice President of Data and In-Memory Technologies Group at Oracle. He leads an amazing team of brilliant engineers in database organization. Shasank, take it away.
Okay, great. Thank you for the introduction. So yes, I'm going to give a quick keynote in about 15-20 minutes, talking about database in memory and really trying to build the motivation behind it. Ranjan talked briefly about real-time enterprises, and that's a major factor for why database in memory is needed now. So let's get started. This is a slide deck that Shasank presented this morning about, how many of these dominant technologies do you use today? We're in 2023 right now. Do we still use I'm going to say teleprompter, but it's not a typewriter. So do we still use it? I can't even say it, it's that old, but do we still use a typewriter? No, we don't use a typewriter anymore. Do we still use these old rotary telephones from back in the day? No. What about these calculators? Do people still use these calculators? Maybe some people, right? Maybe some people use these calculators. Do people still use Windows 95? Be interesting if you can raise your hand in the audience if you use any of these technologies. I'd be very curious to see in 2023 if we're still using any of these technologies. Well, along these lines, we want to move forward. 2028, what will the database architecture look like then? Will it still be disk-oriented, where we're focusing on row-formatted transaction processing done directly on disk? Or are we going to be focused more on memory and everything processed through memory, where transactions are going through row formats, reporting is going through columnar formats? Which one do you think it'll be like? Is it going to be the old way with the rotary telephone, or is it going to be the new way with smartphones? And we're betting, of course, on the smartphone, and we're betting on memory technologies basically guiding the way for almost all data management processing solutions going forward. Now, in memory technologies, they're really essential for real-time enterprises. Real-time enterprises have to be fast. They're data-driven in that they are going to react directly on real, actual data. They need to be agile to rapidly adapt to any of those changes. You can't wait for things to batch, for example. You can't wait for things to process over the network or come from I/O. And you want to be efficient. You need to continuously optimize. You want to configure for one particular scenario, but with the change of the wind, if you will, things have to adapt and continuously be optimized for it. And that's real-time enterprises today. Examples of this are insurance companies where they want to optimize their portfolios and reduce costs using real-time analytics to adjust prices based off of how a person is, for example, for car insurance, is driving. Retailers want to send personalized offers to customers in real time. Who walked into their store? Based on this person's profile, we should send them a coupon, for example. Manufacturing want to be able to use real-time analytics to monitor the quality of and adjust their parameters for their production. Fintech wants to use real-time analytics to do things like fraud detection in real time. And then there's telecom using real-time for congestion metrics to optimize their networks. These are all examples of real-time enterprises. Now, another enemy of real-time enterprises is complexity. So if you see this picture on the right, with a do not touch any of these wires, these are a solution that's built off of many, many different systems and technologies and implementations. And each one of these systems has their own security policy, their own way of configuring things with administration. There are different ways of diagnosing errors. Every piece is different ways for doing updates, patching. And so you're building a solution out of multiple parts where you're welcoming complexity. And that's something that we're trying to avoid for real-time enterprises. And this is like a real world macro example where you pretty much die by do-it-yourself configurations. Here you got these producers that are coming in, doing transaction processing on an OLTP database with Oracle or MySQL, and then they talk to Apache Kafka, which is then feeding into Elk or Apache Flink or Hadoop Lake to do their analytics, and then being fed into different consumers for different platforms. There's multiple technologies, multiple different data stores. The data itself is copied multiple times just to do analytics. So good luck working on a single consistent image of your data. And it's just very complex to maintain, right? If one piece of this, as in this example here with the wires, if one wire is cut, good luck trying to figure out what went wrong. So yeah, do not touch any of these wires here. So an example of this, the problem with these applications, we define something here called Megacart. And Megacart is an online delivery app where you have customers who place orders, you have stores that want to process the order, then you have a separate delivery service that's delivering the orders to the consumer, and then you have analysts in the background that want to check on business metrics, right? Now, as we build this Megacart, the first thing that you need is to be able to handle transactional workload, an OLTP workload. The customer wants to be able to browse items, add items to the order, place the order. The store is going to want to process the order, ship the order, and the delivery service is going to want to schedule delivery and pick up from the store. All of these are basically transactions that need to be, committed, need to follow the ACID requirements. So we begin with transaction, right? So you got the customer and the store and the delivery service all communicating to this operational database, all working on these OLTP tables on the left, the customers and orders and items and so on. And of course, you have these OLTP indexes to make your transaction processing as fast as possible. So far, this is simple, right? This is something that we're used to, and a single operational database makes sense. But now you want to add real-time analytics to this picture. So for example, the customer wants to do some queries and say, hey, what is the top rated phone? Which stores carry it in my region? The store itself wants to do some analytics to ship off some promotions to customers who are interested in certain products based on their location, geography, for example. And the delivery service also wants to do some analytics, like what deliveries could be combined within a single trip so they don't, they save on their fuel costs, for example. So these queries, going back here, these queries would run slowly without analytic indexes. So now you add analytic indexes into this picture, and it's just becoming less simple now. It's less simple because you pay a cost of maintaining these analytic indexes whenever the OLTP indexes have to be updated, or whenever there's any change rather to any of these OLTP tables, then both the OLTP indexes and the analytic indexes have to be updated. And this slows down transactions, right? Okay, so now we want, say, longer term analytics. We want to be able to give queries such as, like, what are the top 10 stores in the Northwest region this month? Or something, what is my year over year sales for a particular product within a certain region? So when you're doing something like this, when you have large amounts of historical data, you really want to offload that to a reporting database. So now you have your operational database, but you're periodically batching and sending, extracting, transforming, loading that data into a reporting database. And now you're basically doubling the complexity. Your reporting database now has its set of tables, its set of analytic indexes. It needs to be, stay as closely consistent with the operational database as possible so that you get really fresh current data results. So it starts to become more and more complex, right? And now, let's say you want to start adding dashboard reports. So these are more, aggregation and joins heavy type of queries. What is my year-over-year growth? What are my top 10 products like this month? How many deliveries were made last week? And so now you want to run these pretty quickly, but you have a ton of data that you have to process through. So you typically get around this by building these pre-computed summaries, or what are typically done are materialized views that then have to be periodically refreshed from the star schema. And so that adds additional complexity now, where you have these MVs here sitting on both, in your reporting database. So it just starts to become more and more complex. And the sources of complexity and efficiency, they're all across the stack. Your operational database has a bunch of OLTP indexes. It has a bunch of analytic indexes. You have now a reporting database that also has analytic indexes and has MVs. And it becomes more and more complex. And that complexity adds more and more overhead. It slows down your transactions. It can slow down your data ingestion. It increases your database size. And that also impacts your reporting time, right? Okay, so what do we really want in MegaCart? We really want to keep this picture here with the operational database, your OLTP tables, your OLTP indexes, but you want your business analysts to still be able to query directly on that operational database. You don't really want to move out of it. And you don't want to have to create those crazy pre-computed summaries with the MVs. You don't want to have to deal with that separate reporting database. And you want your transactions and analytics to all run together and not be impacted by each other. So is this possible? And the answer is yes, this is possible. And the solution here is database in memory. Okay, so database in memory was designed to have real-time analytics with fast OLTP. We don't want to compromise one for the other. And so how do we do this? We basically maintain a single copy of the data with multiple representations of that data in either row format or columnar format. Row format, as we know, is very good for transaction processing. And columnar format is very good for analytics. And so rather than sacrifice one for the other, we thought that we should have a dual format architecture that allows us to maintain both representations and keep them simultaneously active and consistent with each other. Database in memory came out in 2014, around that time frame. And every year since then, we continue to make it more and more performant for analytics and more usable for mixed workloads and making OLTP transactions fast. So very quickly, this is how it looked like. On disk, you still have your table, in this case, sales, that resides on disk like it always does. That's where it is persisted at. And in memory, we continue to keep in the buffer cache the row formatted data, which is useful if you're doing mixed workloads. You don't want to have to go to disk. You can still go to the buffer cache and read your data from blocks that are cached in there. But we also maintain the data in a columnar representation. And there you see that when we populate this table into memory, into these blocks that we call IMCUs, the in-memory compression units. And the rows that are in those blocks are stored in a columnar representation. And we have a very tight mapping between its location on disk and its location in memory. And because of that very tight mapping that we do, we can very quickly update the data in the column store whenever a data has been invalidated, a row has been invalidated because it's been updated or deleted. So that's the secret sauce behind how we maintain consistency between these two very quickly. It does not require the whole database to be in memory, excuse me. You can have even a particular column of your table to be in memory only. So we have lots of different ways for you to keep your data in memory, and we also have ways to automatically maintain that data in the column store, which Andy will talk about. Lots of different technologies here. Columnar format makes scans significantly faster. We can process things in billions of rows per second, as opposed to millions of rows per second that the row format gives you. We keep the data tightly compressed. We keep it in such a representation that you don't have to decompress that data in order to accelerate your scans. You can keep it in a compressed representation. We also have very fast storage indexes that do fast filtering and pruning on the data without actually having to load the data ahead of time. And we leverage all of the hardware capabilities that modern processors have to make scans and aggregations and all the query processing that analytic queries have run significantly faster than what you have in a row store. Okay, I'm going to skip these slides. I'm going to skip these slides also because I know Andy will talk about this, but very quickly, we make joins run faster, up to 10x faster than going up through a row store. In-memory reporting is making aggregation, group by aggregation on top of joins run faster. We've also seen significant gains there, up to 10x. We also, as I mentioned, make mixed workloads faster. Now, how do we make mixed workloads faster? Typically in a mixed workload, you're going to have several OLTP indexes, but significantly more analytic indexes. And whenever you insert a row into a table, you have to update those analytic indexes. Well, you can replace all those analytic indexes with the column store. And the column store is not persistent. And so as I mentioned, whenever you do an update to a row in that table, we simply have to set a bit in the column store to say that the row in the column store is invalid. And that's it. And that's how fast updates are maintained in the column store. And we get very fast analytics because you don't have to have an analytics index on every column. All columns in the column store will give you fast analytics because of the columnar representation in memory. Okay, as I mentioned, since 12.102 is when database in memory was first released, and you can see the progression here from 12.1 to 18C to 19C to 21C and 23C. We're continuously innovating in this area in different categories, performance, focusing on capacity, moving more into automation and self-management, And now moving more into this converged database story, where we want to be able to make sure that Oracle is a one-stop shop for all of your different workloads and all of your different data models. Okay, so database in memory brings simplicity to Megacart. Here you have your operational database, you have your in-memory column store. If you have an Exadata system, you also have in-flash column store. Your in-memory column store replaces all the analytic indexes. Your in-flash column store can replace your reporting database. Your in-memory reporting can replace your pre-computed summaries, your MVs. So all of that is embedded within database in memory. Okay. Analysts as well have recognized our capabilities by consistently rating us high. In fact, not just high, #1 out of the various different vendors, in this case, 16 vendors for all operational use cases. In particular, if you look at augmented transaction processing, augmented transaction processing is the name that Gartner uses to describe mixed workloads, right? So you got transactions as well as analytics running on the same operational database. You look at this Forrester report, this is very new in late 2022 here. And again, this is for translytical workloads or translytical data platforms. That is the term that Forrester uses for mixed workloads. And you see Oracle in basically a league of its own, right? On the top upper right corner, extremely high on our current offerings and the strongest in our strategy across all of these different vendors here. Okay, lastly here, feel free to please take a screenshot of this. This is, if you want to get started with database in memory, here are various different links that you can look up. Lots of ways to evaluate in memory for free. In particular, you look at that second bullet here is the in-memory base level that is available that you can actually use even to productize your solution. You can use it as long as you meet the requirements for base level. And also various different links here, different blogs that we have, different technical briefs that you have. So please feel free to click on those links. And that's all I have, Ranjan.
Yeah.
Hopefully I fit in time here. And any questions, I'll be around to answer them over chat.
Yeah, sure. Thank you so much, Shasank. Those Gartner and Forrester reports are kind of key where, they have, and that shows that there is such a wide gap between Oracle, including in-memory technology with other vendors, right? So those are really key in showing that how advanced our technology is.
Absolutely.
Yeah. With that, thanks, Shasank, again. Let me invite Andy. And so, Andy, please start sharing. So, Andy is a product manager, one of the product managers for database in memory. He spends most of his time helping customers implement database in memory. Andy, take it away.
Thank you. Welcome, everybody, to the In-Memory Summit. My name is Andy Rivenes. I'm a product manager for database and memory. And excuse me, today I'm going to talk about new features in 23C. My email address is there. If you have questions after the session and you want to get a hold of me, I'd be more than happy to answer your questions. We also have, I have my Twitter handle there if you want to follow me on Twitter. And then our blog that Shasank had in the end of his slide. I'll have a couple slides at the end of my presentation as well to kind of highlight that we have a lot of information available to you if you want to explore database and memory. And with that, let's go ahead and get started. So really what I wanted to touch on today, I want to focus on 23C features, but it wouldn't do justice to 21C unless I mentioned that really what you wind up, 19C was a long-term release, 21C was an innovation release, and now we have 23C, which will be another long-term release. So really 23C is the sum of 21C and 23C. And so I have a slightly different take on our journey across different releases as we started in 12.102, and then we have this list of all of these features, as Shasank mentioned, that we have added in the various releases. And so some of the key ones that we'll talk about today would be 12.2, we had join groups. 18C, we had automatic in memory. 19C, external tables was a big one. The mem optimized row store, which actually isn't part of database in memory, but it's gotten a lot of attention. 21C was a kind of a special, this interim release was kind of special in the sense that we really started to improve automatic in memory. And so we added a new level. We made it so that you could literally manage all of your objects, your application objects within the column store automatically through AIM. And we've built on that in 23C with some exciting features. And with that, I'm going to just quickly summarize some of the 21C features, because we've built on some of these 21C features along with previous features to create the new 23C features. And so Shasank mentioned the base level feature, cell memory support. So you only had to specify cell memory. You didn't have to set up a column store. But in-memory vectorized joins is something where we leverage an in-memory vectorized framework to further enhance hash joins with SIMD vector processing. I'm going to talk about that. So what we've done in 23C with that. AIM, fully automatic. We added a high level. I'm going to touch on that as well. JSON as well. And actually in-memory full text columns and in-memory spatial use a feature that we've also leveraged in our JSON support. So I'm going to talk about that as well. So a lot of new things that build on a lot of the things that we've done in the past. So with that, let's get started on 23C and our journey here. So automatic in-memory sizing. I think this sets up one of the biggest changes for us with database and memory and making the column store and database and memory itself more manageable to where it can become fully automated, where you don't have to have manual intervention to size the column store, to fine tune it, to worry about the objects that are being populated. And so automatic in-memory sizing is a feature that works in conjunction or as part of automatic shared memory management. And so now the column store joins something called automatic shared memory management, or ASMM, that based on workload currently allows, in previous releases, allows the buffer cache, shared pool, the other SGA memory areas to be resized based on workload. And now the column store will join that, assuming that you have set AIM or automatic in memory to the level high, which is what we introduced in 21C. So together, these two work to allow the column store to be resized larger when we have heavy analytic workloads and smaller when we have transaction processing. And correspondingly, the other the other memory areas will be sized as well. So it works fully within Oracle's existing architecture to make things simpler for you to manage and not having to know exactly how big to make the column store and when you need to change it based on your workload. We do still require that you set an in-memory size parameter. Kind of my best practice is set the in-memory size parameter to your basic working set size and then let the database manage it. So we have a video here that the development group put together. So I'm going to go ahead and play that. Hopefully you hear the sound this time. I had a little trouble with that in the morning. So let's go ahead and get started.
In this video, I'll show the automatic in-memory sizing. The automatic in-memory will grow and shrink in-memory area based on the user's workload. If it's an analytical workload, the in-memory area will grow. If the workload is OLTP dominant, the in-memory area will shrink and buffer cache will grow. With the benefit of auto in-memory, the in-memory size just needs to be set to a reasonable minimum size. Then it will be adjusted to an optimal size based on the workload to fit the hard disk set. Now let's see a demo of automatic in-memory growth. We started with 8 gig SGA and 2 gig in-memory size. We run tpch query 1 and see it completes in around 1 minute. If we continue running query 1 for 30 times and see the broker's decision, we notice that the memory broker decides to grow in-memory 5 times from 2 gig to 3 gig. After the in-memory growth, for same query Q1, we can see now it completes in around 16 seconds. We achieved almost a 4x improvement. In conclusion, the automatic in-memory size can automate the size of in-memory column store to automatically manage your analytical workload. Thank you.
So there you have it. And so the key takeaway is that the database can automatically resize and based on the workload can really improve performance of your analytic queries by making sure that there's enough memory allocated so that objects can be fully populated into the column store. Let's see if we get back here, and there we go. And as in conjunction with that, we've also enhanced automatic in-memory. So in 23C, we've basically made automatic in-memory is much more aware of the workload that's taking place. And so it's able to now enable join groups where they would be beneficial. In-memory optimized arithmetic. These are features that we introduced in previous versions of Oracle Database. Enable higher compression levels on specific columns, not just the entire object, but on specific columns to better leverage the memory that you have, and possibly unpopulate unused columns to maximize the amount of memory that you have in the column store and the objects you can then populate and have resident in the in-memory column store. Really reduces the manual effort because all of this happens automatically. And in addition to the enhanced analysis, we've also added the ability to track DML overhead. So now the AIM won't be as likely to necessarily populate tables that are undergoing heavy DML, and as that DML maybe subsides as loads have occurred, then those objects might get populated in the column store where they would get the benefit of better analytic processing. And of course, the best part is no application changes are required. And then, so automatic in-memory sizing, AIM enhancements, and now hybrid Exadata scans. And so part of what we've seen with AIM is that AIM wants to have as many objects as possible populated in the column store. That can result in some partial populations of objects. And the thinking there is that even though an object might be partially populated, it's still faster than having it not populated at all. Now, in non-Exadata environments, if an object is partially populated, we'll scan that object, the part that's populated in the column store, and then we'll go to the row store to get the rest of that data. Previously, in Exadata, if the table was less than 80% populated, we wouldn't even access it in the column store. We just do a smart scan against it, hopefully in cell memory if it had been accessed more than once and reformatted, but we go to do a smart scan rather than accessing a very small portion of it in the column store. Now with hybrid Exadata scans, we can access all of the data that's in the column store that AIM is, say, partially populated or that maybe just didn't fit for whatever reason. Maybe automatic shared memory management hasn't fully enlarged the column store. And then for the rest of the data, in that table, we'll smart scan it, hopefully from cell memory if it's been, again, reformatted into cell memory. Otherwise, we'll just smart scan it off a disk. But that's going to give us the best of both worlds. As much as we can get as much as we can out of the column store and then get the rest of it smart scanned out of Exadata storage or possibly cell memory. And so that really gives us three features that work together to really truly automate, especially on Exadata, automate the highest performance possible for your analytic workload. And then another exciting thing that we've been working very hard on is in-memory autonomous database. Now, currently in an autonomous database, we support cell memory. So if you don't even probably know that it's taking place, but cell memory is enabled and can be used today. What we've been working on is adding the in-memory column store to autonomous database as well. So part of that story is automatic shared memory management, the automatic in-memory sizing, I should say, AIM processing, the Exadata, hybrid Exadata scans. So all of that together is also helping us get database and memory in the column store into autonomous database. So they'll be in the UI for the cloud. You'll be able to check whether you want to take advantage of database and memory, and there will be a default column store size, but also a UI slider to let you perhaps make that even larger. Automatic in-memory will be enabled at the default or the default for automatic in-memory will be the medium level. So you still have to enable objects for in-memory. We aren't going to initially go to the high level yet. We're going to be conservative. But once those objects are enabled, then AIM can take over with the population as those objects are accessed with analytic workload and full scans occur. So in-memory autonomous database, I think that's pretty exciting. Selective columns. So we've changed the syntax. In the past, you enable a table for in-memory and you've had to specify columns that you wanted to exclude from population, say columns that weren't involved in analytic queries. With the wide tables feature, where we now in 23C, where we're now allowing up to 4,000 columns to be part of a given table, we decided that the syntax to try to exclude very long lists of columns can be difficult and can force you to go to PL/SQL and CLOBs in order to get strings that are long enough to be able to issue the DDL commands. So what we've done is we've added a couple of all attributes to the in-memory and no in-memory clauses, so that you could say, well, I want everything, or I don't want anything to be in memory. I'm going to specify just a subset of columns. Typically it would be maybe a very much smaller set than the wide columns or the wide table, the number of columns that you might have in total, so that you can do analytics on those. And so you can work this to basically make this a little bit simpler to manage objects where you don't necessarily want to populate all of the columns to run analytics and take up extra space in the column store. Of course, if over time you could let AIM unpopulate those columns, but a lot of times you'll know what your workload is and what you want to do with the objects and how you want them to be populated. We also added something called in-memory rack level global dictionaries. What we've done is we're syncing the IMCU dictionary values across rack nodes. This is to enable join groups to be used across rack nodes. Prior to this, we populated the objects independently across the rack nodes so that join groups would only work on a single instance. And with global dictionaries, now join groups can take advantage of the common dictionaries for an object across all of the rack nodes to give you better hash join performance. That's kind of the bottom line, is we're trying to improve the ability to, we're trying to improve hash join performance. Getting ahead of myself there. And I mentioned in-memory vectorization framework, that in 21C, we added that with single level hash joins. We now are supporting multi-level hash joins along with full grouping and aggregations, semi and outer joins as well, and multiple join keys. So what we're trying to do in the hash join processing is further leverage SIMD vector processing to gain even further speedups. Shasank mentioned the fact that a non-in-memory hash join can be sped up significantly using Bloom filters and hash joins in the column store. And then we added the in-memory vectorization framework to leverage SIMD vector processing. And now we've added further enhancements to that to just hopefully make your hash joins very, very fast in your analytic processing. In-memory columnar JSON. So I kind of alluded to this a little bit. So we've supported JSON in database and memory since 12.2. We added the support for the JSON data type that was introduced in 21C, but that was in the column store. Now we're actually going to support JSON analytic processing and JSON operators in columnar formatted data in cell memory on Exadata storage. And so we've enabled the ability to push down analytics into JSON stored in cell memory in columnar format on the cell memory on the Exadata Smart Flash Cache. And we've used in-memory expressions. I kind of alluded to that we introduced in 12.2. That framework we used in 21C with in-memory spatial, in-memory full text columns, and now in-memory columnar JSON on Exadata cell memory can also take advantage now of all of the processing that we do in the secret sauce for JSON in memory or in the column store. And so that can give us a significant boost, not to mention the fact that it gives you a much larger columnar footprint for JSON processing if that's what you're doing in your applications. And then the other big exciting new feature, I think, is what we're calling the embedded in-memory advisor. We've taken the in-memory advisor, which previously you downloaded off of oracle.com. It was actually a MOS note. We had some tech briefs that described how to make use of it, but it required that you install the package into the database, and that could be problematic for folks that had very large numbers of databases, or as well as folks that have production databases where they can't just go installing a package without going through all sorts of testing and working through whether it's going to impact performance or not. And so with the embedded or the native in-memory advisor, it'll be a package that's built into Oracle database. So now you can run this and not have to worry about downloading and installing a separate utility, if you will. There are two parts to it, an eligibility tool and then the comprehensive analysis tool. We are planning on backporting the eligibility tool to 19C. But I have another video that I want to show you that goes through, talks a little bit about how it works, and then shows you a demo of it. So let's try that out.
Hey everyone, in this video, we'll
And
introduce
hopefully you can hear
version
that
2
because
of
it's as loud as
In-Memory
it goes on my
Advisor,
machine.
a
Yes,
smart
we can
tool
hear.
designed to simplify your journey towards in-memory. Most of our customers have thousands of databases. Some run analytical workloads, some run transactional workloads, and some a mix of both. The benefit in-memory offers is directly proportional to the amount of analytics in the workload. Databases with predominant amount of analytics become the candidate database for in-memory. We can use AWR reports to infer the amount of analytics in the workload and subsequently to identify candidate databases and to quantify the benefits of in-memory. However, it's time-consuming, prone to errors, and almost impossible when thousands of AWR reports needs to be analyzed manually. We solved this problem with the first version of Advisor. It's a downloadable tool that can analyze AWR snapshots and quantify the benefits of in-memory technology without much manual effort. With version 2, we have built the Advisor natively in the database as a PL/SQL package. No need of any additional installations. We have added more capabilities and enhanced the underlying model. Here's how you can make use of Advisor in 2 simple steps. First is the eligibility test. You can ask the advisor if the current database can benefit from in-memory. It will offer you a yes or no answer along with the amount of analytics it found in the database. Using this, you can easily rule out the databases which do not have sufficient analytical activity in them. To run eligibility test, you have to invoke the PL/SQL API that you see on the left-hand side. Let's see a quick demo. We start off by declaring the 2 output variables, and we invoke the PL/SQL procedure by passing 1 as the input, signifying let's analyze last 1 days of AWR data. Now, this database runs predominantly analytical workload, hence we see true in in-memory eligibility. And in the output summary, we see that it has 92% analytics in it. The second step is the advanced analysis. Of all the databases that made through the eligibility test, you can order them in the descending order of the amount of analytics predicted by eligibility test and prioritize the ones with highest amount of analytics and pass them through the advanced analysis. Advanced analysis will offer you insights on the tables that will benefit from in-memory and also quantify the benefit in terms of reduction in DB time. Let's see a quick demo. Advisor relies on real-time heat map stats for its analysis. We start off by enabling heat map. Then we instruct the advisor to start collecting the required stats by invoking start tracking. After sufficient stats have been collected that can represent the workload, we invoke stop tracking. We then invoke generate advice and instruct the advisor to analyze the collected stats. You can view the predictions by querying DBA in-memory advisor recommendation view Here are the predictions for a test workload we ran. Without in-memory, the DB time is around 1000 minutes. When you enable in-memory, you have the option to size the in-memory area based on your requirements and memory constraints. As you can see, Advisor shows the different in-memory sizes, predicted reduced DB times, and also the tables that can fit in the in-memory area. With an in-memory area of 1.6 GB, the DB time reduces by 3 times for this workload. In-memory is truly a transformative technology, and Advisor will be by your side in this transition.
So let's see, let's go back here.
Hey.
I think I forgot to mention, I wanted to mention, because we mentioned it in the demo, that the new in-memory advisor relies on heat map. And so heat map is no longer a license, separately licensed. So as part of Enterprise Edition, you can use heat map. We removed the requirement that you had to have ACO or database and advanced compression option or database and memory license. So the in-memory advisor will work and you can use that without having to license heat map. So you can go ahead and turn heat map on kind of as a best practice. I just wanted to make sure I mentioned that. So where can you get more information? So we have guidelines and tools available on the database resources page. So I'll show you the link to that, a quick start guide, a quick start one pager even, a detailed implementation guide. We have some best practices that we go through in that, and so we recommend that you at least read the quick start guide, because database and memory, it's actually very simple, but it's Oracle database, so there are a few caveats that you should be aware of to make sure that you're successful trying it out. If you want to try it out ahead of time, we have database and memory available in the Live Labs environment, so you can certainly go run it, run all sorts of queries, make use of a bunch of the features of Oracle database and memory right on the cloud. You don't have to have your own tenancy. You can run it for free. It doesn't cost you anything, and you can try it out for yourself. And then, whoops, went the wrong direction. Sorry about that. And then on our blog, we have blogs.oracle.com/memory. That's the page on the left. We have tech briefs and lots of information, articles that we've written about database and memory. And then the resources page, which is a full URL. Again, tech briefs, our Ask Tom office hours sessions, where we've done talked about various features of database and memory and done demos of those features, our YouTube channel, the Live Labs link, and all sorts of other information about database and memory. And with that, I will conclude and turn it back over to you, Ranjan.
Yeah, sure. Thanks, Andy. Thank you. That's a great presentation. As the video mentioned, in-memory definitely is a very transformative technology. Let me just hide this one. So yeah, indeed, a transformative technology. And with 23C, we are actually kind of extending the lead. So you might hear from many other vendors about, hey, in-memory database, but we are, again, extending the lead here with a lot of innovative technologies that Shasank and Andy talked about. It's not just about putting the data in memory. We take advantage of the chip architecture. We take advantage of the extra data bandwidth. We are putting in all these automated intelligence that going in 23C or even in earlier releases. We can accelerate variety of analytics and so forth, right? So definitely a superior in-memory database, and extending the lead here. Okay, so let me kind of summarize a few things. Some of these points were covered earlier, but I want to make sure that you get through more illustration as well. So there is traditional way of getting performance, and it requires application changes. It might require moving and copying of data, manage separate compute, manage separate storage, DBA effort to manage the system, manage security on the additional databases, requires analytic indexes, materialized views, and so forth, right? The whole work kind of compiles. It makes the whole architecture complex and kind of requires movement of data, performance challenging, and so forth, right? But there is a modern and simpler way, which is database in memory. It can turn it on by just changing a parameter. And the key point is it's analytics on live data, right? And you get order of magnitude faster performance, right? And you will hear a lot more from all this customer success story that follows now, right? And so here are I want to summarize some of these customer use cases that we see working with customers across the globe. Many of these customers, they use in-memory to run daily, weekly, monthly, quarterly reports. These are key, right? Every almost organization, enterprises, they have these reports, critical reports, executive reports, dashboards, KPIs, and so forth, right? Or even doing customer analytics, right? These are the key things which is very, very time sensitive and where in-memory shines a lot, okay? And if you are trying to improve your services, introduce new business model, faster operations, scaling your business, adding new data, new analytics, and so forth, right? Or even looking for IT modernization and simplification, again, database in memory will shine there. And this is what has been seen across the customer base. Another look at it from another angle, you may be running variety of analytics, okay? Traditional analytics, mixed workload analytics that we talked about earlier, fusion analytics, text analytics, geospatial, machine learning, and so forth, right? All of this database in memory can accelerate the performance of all this variety of analytics as well. So again, depending upon what analytics you run, you could you try to use in-memory to accelerate the performance. Another key use case is IT modernization and consolidation. I think everybody tried to emphasize this point is about how do we consolidate, right? And not use additional operational data store or data mart and so forth, right? You could bring in all these workloads on a single database, run mixed workload, or even better if you use Exadata, which is Exadata and in-memory are complementary solutions, and you could consolidate a lot of workload on Exadata along with usage of in-memory. Also, if you're using third-party cloud, again, performance could be a challenge there. So you could use in-memory there as well. Let's look at what are the performance benefits that customers have seen. And here you could see many of these are kind of publicly available data and stories. You could see that many customers have seen up to 100x performance benefit, right? And some others, again, the mileage will vary, but you could see that even getting 3x, 4x performance benefit at point time is significant, and even significant for critical workloads and critical queries that customers run, right? So one of the other use cases I want to highlight, and we'll come back with more details in another session, is about SAP BW type workloads, right? We have seen that many a time customers who use SAP BW have significantly benefited from using database in memory, okay? So if you have that kind of workload, get in touch with us. We have a Oracle SAP team that can help in kind of getting started and there, right? So let us know and we can help you there. With that, let me turn over to Arpit Agrawal. And Arpit, could you please start sharing your slides? Let me introduce Arpit. So Arpit works as a database engineering lead. He has around 15 years of experience in database and its associated world. He's also an author of a book on Tableau admin, and he's an Oracle ace. Along with Arpit is Yashwardhan Sharma, who is a senior technical consultant at Fidelity International. Yash is working as data and reporting application support manager with around 14 years of experience. Welcome, Arpit and Yashwardhan. Take it away, please.
Thank you. Thanks. Hello, everyone. Good morning, good evening, and good afternoon. Based on your location around the world, I can see a lot of participants which have joined across the globe, which is pretty cool. And before starting, I want to thank Ranjan and Oracle team for basically organizing this wonderful summit and inviting us to be able to share our experiences with database in memory. I think introduction part is already given by Ranjan, but I'll just quickly recap. My name is Arpit Agrawal, and I work as a senior technical consultant in Fidelity International. I'm a lead of database engineering, author, and an Oracle ace. And I also heavily work towards community building, wherein I'm leader of North India Oracle user group. With this, Yash, would you want to introduce yourself, and then we take it forward?
Sure. So hi, my name is Yashwardhan Sharma. I'm working as senior technical consultant within Fidelity International. I have total of around 14 years of experience supporting various data and reporting platforms.
Okay, thank you. So before starting our journey and the experiences, I would say before implementing database in memory in our space, we had certain business challenges, which was given it to us to solve as a challenge. And let me show you what were those business challenges were. So at a couple of years back, we had various functions wherein we had various reporting solutions for each of those functions. It was not like they were not good. They were good in their own spaces, but as and when the reporting requirement increases over the time, there was a requirement to create a unified solution, which was bringing up a challenge to us, where those scattered reporting solutions were having a duplicate source of truth. So I think in the previous keynote sessions as well, our fellow speakers told you about having the various source of truth or data sources. But when you start having these scattered solutions, there's a very high chance that you create multiple copies of those data sources, which has been used by the reporting purpose. Another challenge which we had was around self-service. Basically, our customers wanted more self-service reporting, wherein they can create their own reports. But considering the amount of infrastructure in the backend and the technology which was there, it was limiting the offering of this self-service. Though it was there, but it was not to the level which we wanted to offer to enable our customer. Moving on to next, we wanted to give even faster response time in terms of reporting with lesser response time. Basically, it was always fast, but we even want to give our customers, we want to even enable more our customers so that our business can function properly. So we wanted to have even faster response time for these reporting requirements. There were certain complexity with the existing solution where those solutions was not capable enough to scale to take down all the futuristic challenges which we had. It also had various challenges in terms of maintenance. For an example, if we needed to stop or start a database or add a column or add an index, it used to take a lot of time, and obviously it required downtime as well. And you can imagine in today's world, it's almost all real time and online changes, and nobody wants to have downtime and wanted to have always on sort of reporting solutions. So this was also another challenge, and we also wanted to have support for various replication technologies. So as you know, reporting data can be stale data or it can be real-time data. But as the requirements are increasing, there was a requirement to have near real-time data support, which can be leveraged through various replication technologies like Golden Gate and others. Next was in the list was platform stability. This was one of the challenge with earlier solutions, where we used to have frequent challenges in terms of keeping the system always on. And we tend to have a good amount of challenges which we need to take care. And the administrator of the platform has to always be busy to make these platforms available. So it was quite an effort, and it was one of the good challenge we had. And in the last, as we know that Oracle and in these relational databases are asset compliant, and we also had this requirement, and existing solution was not having this asset compliance, atomicity, consistency, isolation, and durability. So we were looking for a solution which can basically cater to these business challenges. And after doing aggressive analysis, research, brainstorming, speaking to various vendors, we came up with a solution like this. We actually intend to use database in memory, an Oracle database. And on top of it, for a reporting requirement, we used Oracle Analytics Server now, and then Earlier, it was termed as OBIE. And for our reporting and replication requirements, we intended to use Golden Gate. So if you can see, almost all of these technologies are Oracle-based, and it basically helped us to solve the business challenges which was listed in the previous slide. So database in memory given us a flavor where we can put up the tables which we want in memory for faster reporting. Golden Gate provided us a technology where we can almost on the real-time basis copy the data which we want to use in those reporting from various data mart. And Oracle Analytics Server or OBIE was basically helped us to create those reports on top of database in memory and help us to solve those challenges. Just a very simplistic architecture diagram of what our solution look like. So basically, if you see on the left-hand side, we have a primary Oracle Analytics Server. And on the right-hand side, we have standby OAS. You can see on the primary side is the active side where all the users' workload goes. And there's a standby side, which is actually used for the disaster recovery solution. You can also use DR as a real-time reporting as well, barring the time where web catalog is getting synced from the primary to the secondary side. And you can see at the bottom, it is powered by database in memory Oracle, wherein all the database object is being held in there. And if you see this entire journey, any user who goes to web browser to see their report, based on the load balancer, it is routed to the primary site. And then from the primary site of Oracle Analytics Server, it runs those queries in the backend database in memory. And from there, it fetches a report which are quick enough and then render those views. So this is basically how this entire user life cycle happens. And this is a simplistic representation of the architecture we have. It is important to give you the users pattern as well, that what is the user workload pattern onto the system. As you can see on the left-hand side, we have close to number of active users, which are distinct, is 1,281 in last 6 months. And then total number of dashboard hits. These are the reports which we have on OS backed by database in memory. It is a monthly numbers, which is 98,437. Now these dashboard hit is analogous to close to 223K ad hoc queries which are executed monthly in the backend database in memory database. So you can see power of those database in memory, how good response time it gives. On the right hand side, we have a line graph which tells you how many distinct user monthly are there on the platform and actively using it. So we can safely say close to 1,000 users every month, distinct user every month is using the platform. There is a very small dip in December because obviously this is all free time and holiday times, right? So it is expected, but this platform is very heavily used and one-stop shop for enterprise reporting requirement in our area. There are critical patterns which I wanted to highlight in here. When we started using database in memory, we got a compression ratio of around 5x. That means, for an example, if you have 1000 GB of storage object, we will just need 200 GB of memory. I think Andy also covered that Oracle in memory provide a good compression ratio. So that is what in here we are seeing almost 5x times compression ratio. And good thing is there are joins, there are other scans which can even happen on the compressed data also. It doesn't need to be decompressed and then it requires to scan. But good thing is this technology works on the compressed data as well, which is in memory. Another patterns are we have close more than 150 tables which has been cached in memory. This is a non-exadata solution. And we also run continuously DML operations along with this analytics workload. Indexes also covered in the previous fellow speakers. There were certain indexes when we moved to in-memory database. We analyzed the indexes which were not required after that due to the columnar format, and we then removed those indexes after this. And about the pattern of this workload, it is mostly analytics workload driven, wherein obviously it caters our reporting requirements. I think probably with this, I would hand over to my colleague Yash, who can basically let you know what are the benefits we saw after moving to database in memory, and how does those business challenges turn into benefits after using this solution. Yash, if you can take it forward, please.
Sure, Arpit. Thank you. So, like how we are articulated in the earlier slides, that the challenges which we are targeting to fix after implementing the in-memory database, these are few of the benefits which we have realized. Obviously, like Arpit highlighted earlier, that we have scattered reporting, and with multiple different solutions in place, it was very cost consuming. After implementing the in-memory database, the one thing, the topmost benefit which we have realized is the cost saving. Other than that, with the in-memory implementation, we have introduced a new capability within the enterprise, wherein we have a single reporting platform built and people can use it. This reporting platform again brings in unified reporting. There's a single truth of all the data. People can't have any dirty solutions where they can massage the data or manipulate the data. Instead, all the strategic platforms are hooked up with this reporting platform, and it generates a single truth for the complete enterprise reporting. With using different flavors of UI tooling on top of the DBIM, we were able to generate reports very fast in a self-service mode. There is no dependency on different teams. End user can generate the report on its own with a very little knowledge of basic business data model, and it's very faster. With the implementation of in-memory, we have observed one more thing, that with the earlier versions or the earlier applications implementation which we were using, in-memory is considerably more stable, with a very less turnaround time, where we can do maintenance in a very short span of time. We can ensure that the system is highly available and it is ready for business use with a very little outage. Again, with the support of different replication capabilities with the in-memory, it has bring down our operational cost also, for making sure to ensure that the data which we wanted to move from other strategic source into the reporting platform, we don't have to write too many batch processes, and it gives the data near real time to the end user also. So these are few of the benefits which we have realized. From journey perspective, so this journey started when we saw a business problem, which was around the scattered reporting solutions. People using their own reporting solutions, writing in form of Excel sheets or in form of MS macros and all those things. Then the whole idea came in, wherein we wanted to bring in a solution where it's an automated one. So to minimize this scattered analytic solution, we bring in Exalytics within the organization. For quite some time, use Exalytics. It was OBI plus times 10 Exalytics box. Along with that, ClickView, other vendor product, was also used. Later on, OBI 12.1 was upgraded along with DBIM 12C. With the advent of 19C, again, we upgraded the version of in-memory to 19C. Currently, we are using OS 5.8 version along with DBIM 19C version, and we have realized quite a few gains. Future plans, so yeah, definitely at the moment we are using OS. Future plans will be to explore how exactly we can implement OAC cloud within the organization, explore the different capabilities of DBIM in the later version, or probably if DBIM comes into cloud, we will be planning to explore that as well, because our plan is also to move most of our footprint onto cloud. So yeah, let's see what's there in the offering. Yeah, thank you.
Thank you. Over to you, Ranjan.
Yeah, sure. Thank you, Arpit and Yash. Yeah, this is one of the best implementation of in-memory. As you mentioned, 1,000 users per month, 150 tables in memory, both OLTP and OLAP going on simultaneously. Yeah, one of the best implementation. I give kudos to the Fidelity team for this implementation. Yeah. And
Cheers.
thank you so much for your presentation. Yeah. Okay, with that, let me invite Carrie Dong. Carrie, could you please start sharing your presentation? Carrie is the Solution Engineer, Senior Manager of Technology License Central Team in China. He will cover DBIM and our database in memory stories for 4 China customers.
Okay, hi. Yeah, thanks, Ranjan. So yeah, good morning, good evening, everyone. Yep, I'm Kerry, Solution Engineer, Senior Manager of Oracle China. So I'm glad to share several successful stories in China for DB memory option implementation. Yes, these customers are from different industries. They all encountered performance challenges for their workloads. So DB memory opens the door for them to solve the problem easily. No code change are needed for the application, which is very convenient for them to be adopted. So let's move to the first one. The first one is a hospital. Actually, as you may know, the hospital in China are always huge, which can be visited by thousands or even tens of thousands of patients a day. So these customers, they call it LIS. Actually, it's a laboratory information system. So this system is used to store patient medical examination data. The data is written by examination equipment and can be queried both by the patient and the physicians. So during the peak hour of medical treatment occurs every morning from 8 a.m. to 10 a.m. During this time, the examination equipment writes data to the system, and the doctors and patient perform a large number of queries using different terminal devices. So as a result, the database becomes unable to handle new data insert, and the queries become slow. So the only solution is to restrict the patient access to the examination results queries and limit the physician's access to the system, which results in a poor customer experience. So one of the solutions for them is maybe they could upgrade their hardware to a much more powerful one, or ask the application vendors to rewrite the code. But all of these potential solutions may take quite a long time to be implemented. So the customer cannot wait that long time to do for that. So instead, the customer choose the DB memory option or DB memory features for the tables in this system. Actually, they cache some of the table in the in-memory column store, and it tremendously reduced the reading I/O usage. So this effectively resolved the issue that the data are unable to be read and write simultaneously, so which was previously encountered. So which means actually there were no code change, no hardware upgrade, and it's transparent for their application to use the DB memory option. So they got a very good result for them. So for this case, key takeaways for you maybe DB memory can be used to solve the performance issue for business peak hours. So you need not to upgrade you need not upgrade your hardware, and maybe which may take quite a long time. And however, the DB memory can be implemented online, so you can solve your peak problems just like this customer. So let's move to the next one. The next one is the a securities company. So actually, this security company is in North America. It's a big one, and that his system, there were several type of system for stock exchange. So they need to have data exchange with the stock exchange. And the business impact for them is for their trading system. So for every 3 p.m. every day, after security trading ends, the operation guys would execute a job to clear and settle the date of the day. So the job run very slow. Actually, it's run slowly and slow, slower and slower again. So now and about 2 or 3 hours each time, it cannot meet the business requirement for them because they need to have it run within 2 hours. However, the application vendor could not change the application code to solve the problem issue in a short time. So they have no choice to do performance tuning. And actually, we have tried for them. Mostly it's just run because run out of our resource. So the customer tried the DB memory option for this platform. And after using the DB memory feature, and the user put the transaction settlement tables into the in-memory column store, which can improve this settlement job by more than 4 times faster. And then at the same time, actually, all of this table actually used by the other system, just like the risk control system. And also the risk control system can be run a couple of times faster than before. And because after enable the DB memory, some of the index which used by the risk control and the clearance and the settlement program, they can be removed because they are not, this index are not used anymore. So they drop some of these analytic indexes which can make the transaction process faster. So which means actually in the beginning, they just want to make the batch job to run faster than before, but actually they will make the online transaction even faster than before. So for this case, so the key takeaways for you is firstly, DB memory can be used to shorten the batch job processing. So actually, it's not only for OLAP. So most people just say, "Oh, I just only use for OLAP. I'm not use LAP. I'm just batch job." But you can see actually batch job processing can be benefit from the DB memory because actually you process large number of data. And secondly, so if you have if your application is provided by a third-party application, so it can be also a choice. You can do it, the tuning in the database other than the code. Yep. So let's move to the next one. Yeah, the next one is manufacturing corporation. So the manufacturing is, they have a challenge is to reduce the cost and increase the efficiency because they have a requirement for, we call it Industry 4.0, and they meet many other challenges for this company. The IT architecture should be reconstructed to solve the following problems. First, the current system contains many different types of databases. It's like Oracle, MS SQL Server, or DB2, and any other, also others, MySQL, some databases. So they need to maintain too many different databases. So that is very hard for their DBAs to maintain so many different type of databases. So the second, the analytic queries need to extract and aggregate data from other databases because there are too many databases. So when they run the reporting system, all of the data should be get from the other database. So the reporting system's performance is not guaranteed. So the third one is because for this company, the data warehouse is the core system used by the customer. The current system only support T+1 data exchange model and could not provide real-time analysis capability because you need to extract data from other database. You cannot do it in real time. Yeah. So to achieve the requirements, the customer accept the following proposal, which is provided by Oracle. So first, use Oracle database for the consolidation. So use just one single database for the consolidation. It can avoid cross-database transactions. It can reduce the difficulty of application development, reduce the workload of the operation and the maintenance of the database. So the second, build a unified reporting system. So because we have already consolidated database, so no data exchanging are needed between the database, which are needed before. So now we can achieve the T+0 requirement for the data exchange. So after that, so we'll enable DB memory option to improve the real-time reporting analysis capabilities. Because in the same database, in the Oracle database, so we can enable the DB memory. So the DB memory can improve the reporting analysis performance and the system reliability and for the reports. So after that, so for this company, the takeaways for you is DB memory support HTAP, or maybe we can call it analytic capabilities. So no data moving are needed. So it's good for a T+0 analytic requirements. And it's also a good choice for database consolidation because actually you put many databases inside a single database. Maybe the I/O throughput is not so good. So you can use the DB memory to make it even faster for the report. Okay, the last one is the e-commerce company. So actually this e-commerce company develops some internet platform. It can provide service throughout China. So actually it's for some internet trading services for the other customers. So for this service, actually they are mixed workload. So which means they are consolidate many of the database with multi-tenant architecture. So different type of workloads running in different type of PDBs, pluggable databases. So during the peak hours, so maybe their I/O spikers were observed from time to time. So the customer chooses Redis. Is used to offload some of the OLTP queries to reduce IO pressure on the system. But actually, if you still find the CPU utilization on the system is very low, but still with very high IO utilization. So maybe you can find some active session spike are observed from time to time. So the chief architecture of the company, they want to solve this problem by trying DB memory. Actually, in the beginning, he just want to have a try. So after with the DB memory, the OLAP type of queries can utilize the column store other than the IO. So which means reduce the IO requirement for all of the OLAP type of PDBs. And even for the OLTP queries workload, they are working fine because we have no bottleneck in the IO system. So the Redis are not needed anymore for the OLTP queries. So the Redis service have been removed to simplify the architecture. So you may know if you use Redis for the query owning queries, it can get much complex for the application architecture to do that. And however, after enable DB memory, they still observe some of the IO spikes. Why it happens? So the customer look into their system, find there's some of the instance maybe restarted, and they found some of the table are not get into the DB memory automatically. So he did some research and found, actually Oracle provided a feature. I mean, in-memory have provided a feature is called automatic in-memory. So we call it AIM. So this customer used the AIM to optimize the repopulation of some of the critical tables to the DB memory column store. So after enable this feature, AIM, so even the instance had been restarted by some reason, it can still make all of the critical tables to the DB memory store. So still got the good performance like before. So the takeaway for these customers, first, actually database in-memory is a good choice for a CDB or PDB consolidation for mixed workloads. So if you run different type of workloads in different type of pluggable database, so you can utilize DB memory to make your LLAP even faster. So it's really helpful for IO-bound workload. And actually, it's not only for a single table queries, it also work for multi-table joins. It can make multiple joins even faster. And finally, so if you got some of the critical tables you want to be repopulated automatically to the database, you can utilize the AIM. I mean, the in-memory automatic level set it to make all of the queries, all of the objects can be repopulated automatically into the column store. Yeah, that's all I want to share. Thank you, Ranger.
Yeah, thank you so much, Kerry. So much of insights and details and a lot of key takeaways, variety of workloads where in-memory could be applied and use cases as well to consolidate workloads on single database, to manage peak workloads, resolve the T+1 problem. So yeah, variety of use cases to look after. Yeah, thank you so much, Kerry. Yeah,
thank you.
With that, let me invite you, Shao, to present the Hisense story. So you please start sharing. You is a solution engineer from Oracle China. You has actually published 2 books about Oracle, one about Oracle Timestamp and one on Oracle database in memory. You take it away.
Yeah, you are mute. You need to unmute yourself.
Okay. Hi, everyone. It's great to be here with you today. My name is Xiao Yu, and I'm from the Oracle China AC team. Thanks to our customer Hisense to provide the database in memory use case for language reason. In the next 10 minutes, I will be on behalf of the customer to share the database in memory case studies. Hisense was founded as a radio manufacturer in 1969. After more than 50 years development, Hisense has become a global enterprise in household appliance and consumer electronics with over 80,000 employees worldwide, with the sole aim of delivering first-rate and affordable products to improve the lives of consumers. So let's take a look at our first use case, database in memory and traditional servers. For simplicity, we name it Project H. Before the project, our main problems were slower queries and analysis performance, no disaster recovery protection, and outdated database version. It must point out that the key point is the requirement or architecture principles. Because the server was newly purchased, it has a lot of memory and processing power available. We do not plan to replace the server, and we also want a smooth transformation. That is no change to our SAP applications. It should be pointed out that 18C is the latest version at the time. We have upgraded to 90C afterwards. Okay, let's look at the overall improvement. We sampled a total of 800 programs. The average database response time was 1.47 times faster, and the average program response time was 1.35 times faster. Since these programs run millions of times each month, on average, more than 8,000 hours can be saved each month. We have seen some programs with degraded performance. These are mainly OLTP requests. Since each runtime is a few milliseconds, the overall impact can be ignored. Next, look at our second use case, database in memory on app data. Just like Project H, we also give it code, Project S. We select app data to replace the old Sun server because app data is the base platform to host our database, and it can also enhance our system performance and availability. We also plan to upgrade the database from 11D to 19C and enable database in memory feature. In addition, we plan to use app data to consolidate more and more Oracle database. We sampled 1252 out of 1562 front-end programs. The performance has been improved significantly, and the execution time has been greatly reduced. You can see the month of the upgrade has 16% more number of executions, but the total execution time decreased by 54%, calculated based on 2,000 hours per person per year. 48 people can be saved each year. Using SAP's monitoring tools, you can see from the global work process overview that the number of active instances is greatly reduced, which also indicates that the processing speed of the system is faster than before. To understand whether the database in memory has improved the experience of end users, we distributed questionnaires to 57 departments with an average score of 8.3. The statistics include 4 aspects. More than 80% of users agree that there is a significant improvement, and the users' work efficiency has increased by more than 50%. Well, we now come to the last part. Let's go into some details, how we use database in memory. As you can see from the diagram, database in memory has a lot of features. In current stage, we only use the most fundamental features, which are also the most core and important. We still have a lot of features to explore and leverage. You can also see from this picture that after nearly 10 years of continuous development, database in memory has more and more functionality, easier to use, and more automated. The first tool we use is Memory Advisor. In Memory Advisor is a small tool in database tuning pack. It can differentiate analytics processing from other database activity and estimates the in-memory size and the performance improvement factors. You can use this tool in the evaluation phase. For instance, we mainly use this tool to determine the database objects that need to be placed in in-memory column store. in-memory divisor made a rough estimate of the overall memory requirement. Oracle provides another tool, compression divisor, which can more accurately estimate the memory usage of database objects in the in-memory column store. The actual compression effects are listed here. We compressed 1.5 TB on disk data into 133 gigabit RAM. The overall compression ratio is nearly 12. It can be seen that the compression efficiency is very impressive. For example, the largest table has a compression ratio for more than 15, and the highest compression ratio is 41 times. Actually, there are 6 compression levels for database in memory. The principle is very simple. Just use the default query law. It's the best for query performance, also with relative good compression efficiency. We did a total of 2 rounds of performance optimization. The first round is very simple. Just put the table into in-memory column store by alt table DDL statements. And most of the performance problems are solved in this round. The remaining few performance problems are solved by creating index, forcing a full tape scan, and locking down the optimal execution plan, and so on. In Project ACE, because AppData supports the duplication of in-memory data, therefore, there is a complete column data copy on each instance. Compared with the first project, Project H, we also have good performance, even when some instances are down, because the in-memory data is still there. So it provides better business continuity and performance SLA. So what's the relationship between database in memory and AppData? It seems they can both increase performance. Actually, choosing AppData or database in memory depends entirely on the usage scenario and the goals you want to achieve. In Project H, we achieved our performance goals using only database in memory, but performance does not represent all. Of course, you can choose both of them, like in our Project ACE. You can also see from here that there are many database in memory features unique to AppData. Simply put, database in memory is a feature, a database option, and AppData is a platform. AppData is the best platform for not only deploying database in memory, but also to improve the overall availability, stability, security, and consolidation. For Hisense, in summary, the benefit of database in memory include 4 points. In Oracle 21C or 23C, you don't even need to set the in-memory property. Oracle will automatically populate database objects according to real-time statistics. Okay, if there is only one advantage of database in memory, we can say we think it is the simplicity. We do not need to involve ERP consultants. We do not need to modify the application because the physics structure of the database object has not been changed. Everything is transparent to the application. Perhaps the internal mechanism or algorithm of database in memory is very complicated, but for users, most of the time, just enable it is enough. It's like saying, I don't know how to build a car, but I can drive one. Okay, this concludes my presentation. Thanks for your attention.
Yeah,
okay, right.
Yeah,
For
thank you. Yeah, a lot of key takeaways. And just like I think the last slide sums it up. So we have so much of features and capabilities, but ultimately for the end user, we keep it simple. So that's a key point. Apart from one other key benefit that you highlighted is productivity improvement, right? For the business analyst and all, because they don't get the delayed reports and also they save a lot on productivity. So thank you so much, you.
Okay.
Yeah. So with that, let me invite the last speakers for the last presentation. This is Oracle Database in-memory implementation for a financial services company. We have Manoj S., who is Director of Oracle Solution Engineering, and Tejas Rane and Abhishek, who are part of the Oracle ACS team. Take it away, Manoj and team.
Thank you, Ranjan.
Thank you, Ranjan.
Is the presentation visible?
Yes.
Okay. Thank you, everyone, and a very good day to all the participants who have joined from various countries. So this is again a short summary or use case of what we have seen where in-memory has benefited one of our top customers in India. So this customer runs a very volatile kind of environment where based on seasonal patterns, based on demands of various scenarios, his data patterns change. So he doesn't have a kind of a settled system, and his query patterns change. He has abnormal behavior seen because of the changing data patterns. So here, our Oracle ACS teams have been engaged along with me from the solution engineering, working with the customer for quite a long time, helping them fine tune and get the best performance from their systems. So just let me introduce the team on the ground. So we have Abhishek Veer, who is the technical account manager from Oracle ACS, and he manages the customer, and he takes care of all the issues, performance optimizations which occur at the customer side. Again, one of the key persons who's done this optimization is Tejas Rane. He works actively with the customer, doing the database optimization, improving the performance of the systems at the customer. And myself, I work actively with the customer, getting them, the right solutions in place, advising them on, what would be the right fit for the problems they are facing from a architecture and a solutioning point of view. So before, I'll just move to the what were the challenges specifically for this discussion. So yeah, like I mentioned, customer has a volatile kind of environment where his needs keep changing. So here, one of the things observed during one of the changes was one of the batch processes was taking approximately a long time to run. So originally, this process used to complete in few seconds and had fewer executions. But due to a change in business logic, this led to an increase in executions. So post that, what would happen is what would complete in within 10 minutes or so. It ran for 4 hours. So this kind of created a panic situation at the customer end, and their expectation, the business expectation was it should run as it was previous before the code change. So with that, I'll hand it over to Tejas to walk you through what exactly happened, what was the customer's environment, how they handled it, and what what they did using the in-memory, which helped regain customers' confidence and prove the product capability. Yeah, over to you, Tejas.
Yeah, thanks, Manoj. I'll present this slide now. Okay. Firstly, my first motto to all of to explain the situation what we have faced on our site and how we resolved their issue, which saved their business SLAs and penalty from one of the largest organizations for stock exchanges in India. Okay. So basically, there was one release from application end, which has increased the table data, and with the row level of approach which were used in the procedure, the executions got increased from 500 to almost 4,000, and that too it took almost 4 hours. So specifically elaborate more on it from technical perspective. This is the scenario. And as business was not aware how much more executions are going to be there and how much more time it will take. So we had to take a call for boosting the performance right in front of the business users and business heads. Okay. So as we have already implemented in memory on our side for more than 50 to 100 tables, which are divided into 4 to 5 databases. So we took a call to implement or add this settlement deposits table in memory. So with maximum number of distinct columns which are having in this particular query, which was using this table. Okay. So we added this table into in memory as it was having large number of DMLs, and we did not want to create an index which could add an overhead again for maintaining the indexes. We added this table into in memory, and which gives us the result for next 8,000 executions in next 15 minutes. And to just add one more point, as in memory is in the lightweight feature, which I can say, as indexes are comparatively, indexes are more it stores row IDs and other stuff, and whereas in memory uses the IMC units, that is in memory compression units, which internally stores the minimum and maximum value of every column within that table, which acts as an storage indexes in memory itself. So that is the reason we use the in memory, and which helps the customer at that point. Thank you. I'll hand it over to the Manoj next.
Yeah, thank you, Jesus. So, friends, here definitely all the capabilities which are spoken about in the in memory, right? The columnar format, the columnar format, the compression, right? So that it fits inside the in-memory size, the storage indexes, so that whenever the query hits, right, it eliminates and doesn't go to a complete scan. Plus the capability of SIMD vector processing, where multiple values are processed in a single CPU cycle. So we see this complete, the actual implementation, helping in improving the business processing. So all these capabilities of in-memory, in a nutshell, helped taking a 4 hours batch job to be completed in 8 minutes. So another few things to highlight was, since this was a rack setup running on Exadata, duplicate all was used so that all nodes could benefit from the in-memory. Plus, because it was a heavy read-write kind of operation, compress for TMLs was also used, so that it could sustain, as and when the data was written, it was populating the in-memory column store, and it was helping in a faster execution. So ultimately, because of the fix done by Oracle ACS engineers on site, the business SLA was met, and like they just added certain penalties were avoided because of longer settlement cycles. To summarize this, what was originally gone out of hand due to the change of code, was brought back using the in-memory technology, and thanks to all the capabilities of in-memory, we saw that this implementation improved the overall performance by 30x. So what were the products used? Oracle Database 19c, Oracle Database in-memory, and Oracle Exadata. So I would say these two definitely helped in boosting the performance. And with additional Exadata, there are additional capabilities which always help in faster retrieval of data. With that, I would like to end this use case presentation, and back to you, Ranjan.
Yeah, excellent. Yeah, thank you so much, Manoj and Manoj, Tejas. Very interesting presentation. Imagine what you could do if you could finish some business process which used to take 4 hours in 8 minutes, right? So, I mean, definitely, it's a great optimization. Okay, so let me kind of conclude on the summit. So I mean, as we have seen across the different presentations, right? And we saw various case stories from various industries, various countries, and various types of use cases as well. So database in memory has been kind of proven in, like I said, various industries for various types of use cases. If you have any use case, yeah, let us know. We can work together, and I'm sure we can make you help become successful there. So kind of call to action here. The best time to use database in memory is now. Data and analytics is kind of exploding. The type of analytics is exploding. Data, amount of data is also exploding. And data analytics is kind of key to many of the business processes and all. And there's a lot of different benefits out of it, including the IT simplification and modernization, right? So again, to my point earlier, let's collaborate and share your business requirements, use cases with us. We can help you, we can guide you in the implementation. And also, if you have any feedback, suggest us any feedback, enhancements, and so forth. And let's continue the discussion after the summit. Again, we could help organize technical sessions, workshops. We could do POC support as well. So yeah, let us know how we can help in the process. Again, let's build the solution for the future. I think Shasank highlighted that we are looking forward with all these innovations and all, and we want to take the journey with you and implement one of the best kind of solutions for the future. With that, are there any questions? Let me just stop the recording.